Welcome to Chapter 7, Section 7.3. We're going to cover drop sets and infusion rates. As you can see from the marker board, pharmacy staff and the nursing staff are responsible for calculating the rate of administration for IV fluids, and that's represented as drops per minute, and it's abbreviated as GTT over minute or drops per minute. Now, when we're calculating the flow rate, it's important to remember that manufacturers produce IV tube sets and they have different size drops. So if you look at the figure on page 189, figure 7.1, that shows us some sample drop sets and some common sizes. Some of the more common sizes are 10, 15, and 20 drops per minute, and those are referred to as macro drops. They have larger drops coming into the IV. And then we also have a mini drip, which would be 60 drops per minute. And those are considered micro drops. They're tiny little droplets. And these are going to be commonly used in children who are critically ill and are being given medications that have a very narrow therapeutic window. It's also important when we are calculating drop sets and infusion rates to round down if you have a partial drop or minute is calculated. If you don't have a full one, instead of rounding up, even if it's a higher point like 20.8, you're still going to round down to 20. Okay, so let's take a look at example 7.3.1 on page 189, and let's go ahead and do one of these problems together. I'm going to go ahead and write out the formula for calculating drops per minute. And drops per minute is calculated as the volume of fluid divided by the delivery time. And I'm going to run out of room here. Times the rate of drops, or the drop set. I'm just going to put D for drop rate, over 60 minutes and an hour. Okay, so let's look at example 7.3.1. If an IV is running at 60 ml an hour, what is the rate in drops per minute using a 15 drop set? Okay, so the volume of fluid is 60 milliliters per hour. So 60 mils divided by an hour, so the volume of fluid divided by the delivery time, times the drop rate. We know the drop rate is 15 drops per ml. And we're going to divide that by 60 minutes in an hour. 60 divided by 1 is 60 times 15. And we're going to divide that by 60. And that's going to give us 15 drops a minute. Okay. So let's take a look at our 7.3 problem set. And work out a couple of these problems together. Let's look at number 1 just to start off. An IV rate is 10 ml an hour. If a 10 drop set is used, what will be the rate in drops per minute? So we're looking for drops per minute. We're going to use the formula we just went over. So the rate is 10 ml divided by 1 hour, which is the delivery time, times our drop rate, which is 10, divided by 60 minutes in an hour. 10 divided by 1 is 10, times 10 is 100, divided by 60, and. and that is going to give us X equals 1.67, but remember we want to round to 1 drops per minute. Okay, let's look at number 2. What is the IV flow rate and drops per minute for a child who's receiving 30 mLs per hour, or I'm sorry, 35 mLs per hour using a 60 drop set? And I'm just putting DR for drop rate. Okay, so according to our formula, 30 mLs divided by the delivery time, which is an hour, times our drop rate, which is 60 drops per ml, divided by 60 minutes in an hour. Okay, so we've set our formula up. We'll go ahead and solve. 35 divided by 1 is 35 times 60, which is 2100, divided by 60, and that gives us 35 drops per minute. It's pretty simple after you get comfortable plugging your formula in. Okay, let's look at number 3. A patient is to receive 1 gram of medication and 100 mLs over 1 hour using a 10 drop set. What is the rate in drops per minute? So we have 100 ml divided by 1 hour times 10 drops per milliliter, and over 60 minutes in an hour. 100 divided by 1 is 100 times 10 divided by 60. And that works out to 16.67 drops per minute. But remember, we are going to round down because that's not whole. We're going to round back down to 16 drops per minute. Okay, let's look at number 4. A nurse will be administering 500 milligrams of medication and 50 mLs over 30 minutes using a mini drip set. And remember, we said a mini drip set is 60 drops per milliliter. What is the flow rate in drops per minute? Okay, so we have our volume, 50 ml, divided by the delivery time. Normally this is 1, but it's not a full hour, it's 30 minutes, so it's a half an hour, times our drop rate, 60 drops per milliliter, divided by the time, which is always 60 minutes in an hour. Okay, 50 divided by 0.5 is 100, times 60 is 6,000. Whoops, you can't really see that. 6,000 divided by 60, so X is equal to 100 drops per minute. Okay, let's turn the page and look at number 18. This one is a little bit different. Okay, a patient is to be given 1 liter of dextrose 5% in water and normal saline and 1 milliequivalent of potassium chloride at the rate of 125 milliliters an hour. What will the drops per minute rate be if a 10 drop set is used? Okay, so don't let all that information confuse you. They're still asking for the drop set and the drops per minute. So the only information we really need to pull from that is the 125 mils per hour. We need to know how much and what the delivery time is. And we also, part A tells us that a 10 drop set is being used. And again, it's going to be divided by 60 minutes in an hour. And we're just going to solve a formula. 125 divided by 1 is 125 times 10 is 1250. Divided by 60 is going to give us 20.833. But remember, this is not a full drop, so we're going to round down to 20 drops per minute. Don't let all the extraneous information confuse you. Okay, let's look at B on number 18. What will the drops per minute rate be if a 15 drop set is used? Okay, so same information. Still 125 mils divided by an hour, the delivery time. Except this time we're using a 15 drop set. And as always, 60 minutes in an hour. 125 divided by 125 times 15 is 1875 divided by 60. And that is going to give us 31.25 drops per minute. But again, this is not a full drop, so we're going to round down to 31. Okay, and let's look at C for the last one. This one, the drop set that we're using is 60 drops per mil. So remember, this is still the same information from A and B times a 60 mini set over 60 minutes in an hour. 125 times 60 is 7,500 divided by 60, and that gives us an even 125 drops per minute. Okay, so hopefully that has helped clear up any confusion you might have had looking through some of the examples. If you have any further questions, feel free to post them to the virtual office or to the discussion thread.